If n is an integer and n squared minus 2 equals 0, then n equals 2. This statement is actually true. At first glance, this looks false, right? Because if n squared minus 2 equals 0, then n equals the square root of 2, not 2. So how can this statement be true? Let's prove it. Instead of proving the statement directly, we will prove the contrapositive. The contrapositive is, if n is not equal to 2, then n squared minus 2 is not equal to 0. This is actually obvious. If n is an integer and not equal to 2, then n squared minus 2 can never be 0. Why? Because n squared minus 2 equals 0 only when n equals plus or minus the square root of 2. And the square root of 2 is not an integer. Therefore, the contrapositive is true. And when a contrapositive is true, the original statement must also be true. So even though the statement looks false at first, it is actually true. Why does this happen? Here is the key idea. For any statement of the form P implies Q, if P is false, then the whole statement is always true. This is called vacuous truth. We can also understand this using sets. The statement P implies Q means that the set of P is contained inside the set of Q. So whenever P happens, Q must also happen. But if P is false, then the set of P is an empty set, and an empty set is always contained inside any set. So as long as the set of Q has at least one element, the statement P implies Q becomes automatically true. That is why a statement that looks false can still be logically true. In this example, the statement n squared minus 2 equals 0 is never true for any integer n. So the condition P is false, which means the entire statement is true. Did you understand this trick? I'll keep posting interesting math videos like this. If you enjoyed the video, please like, comment, and subscribe.